Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss about prediction-oriented segmentation POS in SmartPLS-4. There can be two types of heterogeneity in the data. One, the observed heterogeneity, and another one is the unobserved heterogeneity. The observed heterogeneity is one in which researcher is aware about that the model can differ according to the observable characteristics such as gender, occupation, education. Or if we talk about any industry, it can be that the model may be different for a large scale industry or a small scale industry. But when we talk about unobserved heterogeneity, the researcher is completely unaware about the segmentation by which the model can differ in some groups. These groups are completely unknown to the researcher. Now, to identify such type of heterogeneity, we used to run the clustering techniques, which is considered to be the age-old tactics. The advantage of running cluster analysis is it is very easy to apply segmentation. But such an approach, the cluster analysis has got some limitations. It cannot work. The cluster analysis cannot work on path models. So to do the segmentation of the path models, we are having two latent class techniques. Now, according to the Becker et al. 2013, Rigdon 2010, if we fail to consider such heterogeneity, it can be a very serious threat to the validity of the PLS-SAM results. Moreover, according to Zedadi et al. 1997, the assumption of relatively homogeneous data, that is, the entire data coming from the homogeneous group, is often unrealistic. Now, according to Zedadi et al., there may be a significant heterogeneity in the data across the unobserved groups, and it can bias the parameter estimates that will lead to type 1 and type 2 error. So we have to consider that the model may come from the heterogeneous groups, and we have to consider the unobserved heterogeneity in our data. So there are two latent class techniques to capture this unobserved heterogeneity. One is FIMIX and another is a prediction oriented segmentation. FIMIX, that is a finite mixture models. This I have already discussed in my previous video. I will request all my viewers to kindly refer my previous videos to understand the flow of this entire lecture series. Moreover, these latent class techniques have proven very useful to identify unobserved heterogeneity and partitioning the data accordingly. Now let us understand that when we are running a model on full data set, we may get the path coefficients P13 is equal to 0.30 and P23 is equal to 0.30. And we may feel that the results, that is y1 is affecting y3 with the same magnitude as y2 is affecting y3. But when we group the data, that is group 1 and group 2, it may be possible that P13 may take a load of 0.50 in first group and P23 0.1 in the second in the same group, it may take a load of 0.1. In second group, it may be possible P13 takes a 0.1 and P23 takes a 0.5. So when we aggregate the data, we may get the different picture. Now, to account for this unobserved heterogeneity, we are having two models. One, FIMIX, that has already been discussed, and another is a prediction-oriented segmentation developed by Becker et al. 2009. There are some other methods also for segmentation in PLS path modeling, like PathMOS, distance-based, but most popular are PLS-POS, that is a prediction-oriented segmentation, and FIMIX. The advantages of prediction-oriented segment is, the first is, it uses a specific objective criterion to form the homogeneous groups that maximizes the explained variance R square of all the endogenous latent variables in the PLS path model, and thereby takes the entire path model structure into the consideration. The basic objective is to maximize R square of the two segments. Second, it includes a new distance measure that is appropriate for the formative measures, and heterogeneity within them is also considered. Third, It reassigns observation only if reassigning observation improves the objective criterion. Otherwise, it will not do it. The latter feature of PLS-POS ensures a continuous improvement of the objective criterion throughout the iterations of the algorithm, and that's the reason it's known as a hill climbing approach, where with each iteration, we are trying to improve the result continuously. This provides the ability to uncover very small niche segments also. It's like finding out the local optimum in each iteration. The difference between Phimix and POS is Phimix can work well on reflective construct. POS can work well on reflective as well as a formative construct. Phimix, it's better with the formative construct having a high multicollinearity. POS not better with formative construct having high multicollinearity. Phimix works well on non-normal data. POS works well on normal data. Heterogeneity is expected to affect structural model. In case of POS, heterogeneity is expected to affect structural as well as the measurement model. Now, there are some steps for running the POS which we will have to understand. The first question which you should ask is the stage 1. Yeah, stage 1. Is the selected approach a Latent class approach or a segmentation method? So, if it is a Latent class, move ahead, say yes. In other cases, you will have to go for fixed effects, random effects, and other types of segmentation. Here, we are going for Latent class. That's a segmentation method. Apply the segmentation method to define the segments that you want, for which you want to run the algorithm. That is for how many segments you want to run this segmentation method. 1, 2, 3, 4, or 5. Then comes step 1. Use several heuristics to narrow the range of statistically well-fitting segments. Now, what do I mean by heuristics? Heuristics means researcher's own decision. The researcher has to take a call what he will run, that is, for how many segments he will run the algorithm. Researcher have to rely on heuristics to determine a well-fitting number of segments, as there is no exact statistical test to accomplish this task. This is according to the McLehan and Peel 2000. So it's a researcher's decision to determine the well-fitting number of segments. POS method requires other model specific heuristics to compare the results across the different number of groups. For example, in terms of average variance explain or increase in predictive relevance Q square. So POS method requires other model specific heuristics. Here, we are just focusing on the researcher has to take a call on his own. Now, once the researcher has identified, according to heuristics, that the segmentation will be done for 2 or 3, then comes the next step. We should ask, is the segment substantial or not? It means that if we divide the data into 2 halves, then more or less this segment should be equally divided into 2 halves. It means that the equal representation should come in both the halves. For example, if we are having a data, the sample size is 100, and we divide the segments into 2, at least 50-50 representation should be there in both the segments. So there should be enough representation coming from groups or segments identified by the researcher. This is step 2. Therefore, each segment has to be large enough to represent a real segment. However, one also needs to be cautious when contrasting the niche and irrelevant segments. It may be possible that you may get the niche or irrelevant segments. It may be possible that we may get many segments because of the presence of outliers. You can see here. And therefore, you may get many segmentation because of outliers, bad respondents, statistical artifacts, or data collection problems. So if your segments are not substantial, no, then you will have to address that issue and you will have to come back here, removing the outlier, removing the bad respondents, and after removing, you will have to get the substantial segments. The step 3 is the segments differentiable from other segments? This means that by running the multi-group analysis, we want to see that is there any significant difference in path coefficients according to the segments or not. So once we get this, we'll be running multi-group analysis. If no, it means that the segmentation technique is overfitting the data. If it is no, then the segmentation technique is overfitting the data because of the number of segments specified for extraction. And segment is not statistically different from others and therefore should not be treated alone. It means that if the multi-group analysis confirms that two paths are having more or less same loading, it's not necessary to report the separate result. So if a segment is not statistically different from others, it means that the path coefficient of group 1 and path coefficient of group 2, they are not statistically significantly different. Researchers should consider either combining the segment meaningfully with other segments that are not significantly different from it, or reducing the number of segments in the segmentation method. The next step is step 4. Are the segments plausible? We are having the segments that are substantial and differentiable, but is it plausible? The segments which have been identified by heuristics and algorithm, can we give enough explanation with the help of theory or model? See, we have ran the algorithm and the algorithm is saying that there is an undercurrent which is passing, that your model is different according to this segment 1 and segment 2. But are we able to provide any construct? Are we able to provide any theory? Are we able to provide any model which can validate this segment? So does the conceptual difference exist between the segment and other segments? We will be able to do the segmentation. Then only we'll be able to do the segmentation, and those segments which we have got it, are they having any managerial relevance or not? Now, the next step is step 5. Is the segment accessible or not? The question here is that after doing the segmentation, will I be able to convert the unobserved heterogeneity? See, the unobserved heterogeneity into the observed heterogeneity. The segments are accessible means, will I be able to carry out the advanced statistics such as logistic regression or discriminant analysis or chi-square on the segments or not? If yes, then we will proceed further for running the multi-group analysis, that is stage 3. Now, how we will run prediction oriented segmentation, let's see in SmartPLS. So we will go from here, activate the HBAT. Now you can see here, this is a model, job satisfaction affecting the staying intention of an employee, organizational commitment affecting the staying intention of an employee, environmental perception affecting the staying intention of an employee, co-workers affecting the staying intention of an employee. Now we want to see that is this model different according to the unobserved heterogeneity. For observed heterogeneity, say for example, gender, we have already discussed in the multi-group analysis that how we can do this. But for unobserved heterogeneity, first of all, we will have to do the segmentation. So for this, I'll go and calculate prediction oriented segmentation. Two groups are there. Fimic setup, everything remains safe. Run, start the calculation. Now you can see two segments have been identified, segment 1 and segment 2. Now you go in, open the reports. First of all, see the segment sizes. So group 1 consists of 334 members and group 2 consists of 66 members. It is quite biased, but for our understanding purpose, we will consider it. See, if we go according to the first step, what is our first step? The segments should be substantial. It means that enough representation should come from both the groups. Here, there is a biasness in the sense that enough representation is not there. This you can see from segment size and relative sizes also. The next thing which you should see is the R square. This is the R square for segment 1 and this is the R square for segment 2, and this is the average weighted R square. This is the R square considering the heterogeneity, unobserved heterogeneity in the data. And this is the R square when we don't consider the heterogeneity. Now to proceed further, it is necessary that your uh, heterogeneity after segmentation, that is R square, after segmentation should be higher than this one. Then only we should proceed further. If R square is higher than this, it means that the unobserved heterogeneity is in the model, and if we consider it, our R square improves. The another concept is why we are going according to this method is, if you recall, the basic objective function of POS is to maximize the R square. So if we are not able to maximize R square, there is no point in considering the unobserved heterogeneity in the data. And that's the reason this R square, after considering the segmentation, should be more than the base model. There can be a situation in which this R square is less than the base model. In such scenario, we will consider that there does not exist any unobserved heterogeneity, and therefore it is not necessary to report the separate result for group 1 or group 2 or segment 1 or segment 2. Now let us see the results of original path coefficients. This is the results which we get when you consider the full data set. This is segment 1 and this is segment 2. You can see the loadings here, that for co-workers it is 0.049. That is the effect of co-workers on staying intention. It is 0.049 in segment 1. And in segment 2, it is taking 0.430. Quite surprising. The loads are different in both the segments. So let us go in the graphical output and try to understand. The job satisfaction, increase in job satisfaction by 1 unit in segment 1 is affecting staying intention by 0.06 unit. But in case of segment 2, this is 0.170. Now, in segment 1, organizational commitment is affecting the staying intention with 0.450. Path coefficient is 0.450. But in case of segment 2, it is quite negligible. Okay. Now, in segment 1, again, environmental perception is 0.134. In segment 2, it's 0.730. Segment 1, behavior of co-workers and its effect on staying intention, 0.049. In segment 2, it is 0.430. And therefore, the difference is there. Now we will have to run this multiple group analysis and try to identify that is this difference so large that a separate, the results should be reported separately for both the groups or not. Now the segmentation done by SmartPLS, we have not incorporated in our raw data file. So we want to incorporate this. You can see here the segment assignment is there, that where each case has been loaded in first group or second group. Now in the new features of SmartPLS, you can incorporate this thing directly. So create the data file and tick on all of them, create. Now press the edit button, back, and you can see here that HBAT SAM derived from POS results is activated. Now you can see here that the final partition is activated, where the data has been segmented into 2 groups. Now I want to generate the groups. So I'll go here and click on final partition. And I'll write down here the segmentation according to POS. There are 2 segmentations. This is the value, the first, this final partition, it is because of the Femix partition which I had done. So I'll take the second one. Press apply. You can see here that 334 and 66, which we have seen earlier, it's the same segmentation. If I want to give the names, I can give the name here. Otherwise, I can keep the things simple. And I will go back on the data. So the segmentation is completed. Now I'll go back on the data, HBAT. Make sure from select data set, your POS result is active. Now I want to run the multi-group analysis, and I want to see that are these path coefficients significantly different in 2 groups or not. So for that, I'll go and calculate. bootstrap multigroup analysis, select POS1 from here and POS2 from here, and start the calculation. Again, it will give me POS1, POS2. Okay, click on open the report. Directly go in path coefficients. Now you can see here that we will get bootstrap MGA, parametric test, Welch-Satterway test, and bootstrapping results. So if your assumption is that the variances between the two groups are equal, you use parametric test. If you assume that the variances are not equal, you use the non-parametric test, which is a Welch-Satterway test. Normally, we consider the results of Welch-Satterway test. Now you will have to see the p-value here. Those groups whose p-value is less than 0.05, it means that significant difference exists between these two groups, and therefore it is necessary to report separate path coefficients for these two groups. But those path coefficients whose p-value is more than 0.05, it means that the job satisfaction affecting the staying intention, their path coefficients are more or less equal, and therefore it is not necessary to report the separate path coefficients for these two groups. The same thing we can confirm by confidence intervals bias correcting. You can see here, if 0 is not present in between this two confidence interval, then these path coefficients are significantly different. So 0 is not present. Here also the 0 is not present. But here in organizational commitment to staying intention, 0 is present. In Welch-Satterway test, it is giving me the p-value less than 0.05. So more or less you should you should rely more on p-values rather than confidence intervals. So here it is 0 to 0, but still Welch-Satterway test is giving me the p-value more than 0.05, and therefore this difference is not so large that we report the results separately for two groups. Now to get the separate results, or we want two models. So for that, I'll go and calculate PLS-SEM algorithm and make sure that in data, this time you select POS1 and POS2, start the calculation. So you can see here, this is a complete model, POS1 and POS2. So what is the last step? That is a stage 3. Let us try to understand. Validating the segmentation results. Once you run the multi-group analysis, and if there is a significant difference exists in the segment, you will have to check. If the significant difference exists, heterogeneity is present. If the significant difference does not exist, then the heterogeneity is not present. So here, in this case, you can report the separate results from here. See, POS1, the path coefficients, and POS2, the path coefficients. So for more videos on SmartPLS, kindly subscribe to my channel. You can also follow me on LinkedIn and Twitter. Please don't forget to press the like button. You can see my playlist in which I have already uploaded many videos related to SmartPLS. Thank you.